Hello my dear students. So today we are going to solve this sum from the equilibrium chapter. Before solving this sum, I will give you information about my classes. So I take tuitions for Ibdp and IGCSE, it's A levels also, and even MYP 4 and MYP 5, but it is purely for Ibdp and IGCSE. So you can opt for either online class or offline class. I will tell you one important thing, that if you are going to opt for online class, then the fees is 1/10 of that of the offline class. If you are staying outside Mumbai from anywhere in the world, you can opt for our offline class. So this is my email ID. Here my email ID is class@mumbaiedutech.in. So you can drop mail over here, and then I will respond. So you can, if you are interested, you can drop mail. Note down this mail ID. Okay, now let's start the sum. Here, as you can see here, the question is that the following equilibrium is established at 1700 degrees centigrade. CO2 plus H2 is reacting to form water and carbon monoxide, CO, but here they haven't written plus, so here it should be plus in between. So now let's solve this question. Okay. So here they have asked, if only carbon dioxide and hydrogen gas were present initially, sketch on a graph a line representing the rate against the time for forward reaction, reverse reaction until shortly after equilibrium is established. So we will first draw this. So here we will draw y-axis, and over there we will write rate. This is rate, and x-axis we will draw. So on the x-axis we will write here time. So now we will draw the graph. So let's put the value of time x-axis. So it starts, suppose it starts from 0, then we will assume that 4 seconds, after 4 seconds, then after 8 seconds, after 16 seconds, and after 20 seconds what happens. Now in the same way, on the y-axis rate is given here, so we will write the values for here. Rate 1, 2, 3, 4, 5, 6. So we will do the first part, the forward reaction. Line representing rate against the time for the forward reaction. As you can see here, as initially they have given here only carbon dioxide and hydrogen gas is present. So here concentration of the reactant is more here. So concentration of reactant is more here, and product has not formed at all. So that means it will start from the highest point. The rate will be highest here. It will start from 6, that is maximum. Here on this I have written 6 as for the rate, so it will start from this 6 here like this. So here it will come like this. Okay, so from the maximum, then it will come to equilibrium position at the center. Around here 3 is there, so this is the equilibrium position, so it will come. Now for the second part also we will do for the reverse reaction. So sketch a graph of line representing rate against the time for the reverse reaction. So until shortly after the equilibrium is established. As they have written here that carbon dioxide and hydrogen initially was only present, that means product form was 0, so it will start from 0, and rate is also 0. So product form will be 0 for our this product one. Okay, that is reverse reaction. So reverse reaction I will make with yellow color. So this is our yellow colored reverse. So this is reverse reaction, yellow colored, and green colored is for our forward reaction. Only reactants are there present initially. So after some times you can see reactants are getting consumed here, and it has reached the value where reactants are now here. Rate of both have merged here to form a parallel line with the x-axis. So both the lines, when it becomes parallel in any graph, that means the values have become constant here. So that means neither the product is being formed nor the reactant, means total amount of reactant and total amount of product is now whatever it was there, means what it has reacted, now it has come to equilibrium position. So it has reached the equilibrium. Now neither reactant is combining to form product, nor product is breaking up to form reactant. So this will be the whenever it becomes parallel to x-axis, that means this. That means our neither the reactants are breaking neither the reactants are combining to form the product nor the reactants are breaking to form the reactants. So this you should remember. So now here this way you can draw the graph. So this you should remember always. Whenever at the initially what will be there, initially the reactant will be more, so rate will also be more because reaction has just started. So the combining of both the reactant will start, so that's why rate is at the highest point here 6, and after sometimes it will reduce because the reactant is combining together to form the product. Now here it has reached to this position which is parallel to the our x-axis. Even then what happens at the same time, our when reactant is combining, when it is getting reactant combined to form product and it is getting lowered, so even what happens here, rate of backward reaction is equals to rate of forward reaction. That means even green, you can see green line has become parallel at 3, this one, and even yellow line has become parallel to the x-axis at this 3 only. So both of them has become 3. So that's why rate of backward reaction is also 3, and rate of forward and rate of backward both are at 3. So we can write in this way. So rate of backward and forward is at 3. That means rate has become here 3. So that's why we can say in this way it has come reached the equilibrium position. So let's do the next part of the question. So next part of the question here is Kc for the equilibrium is determined by at the two different temperatures, at 850 and Kc 850 it is 1.1 and at 1700 degrees centigrade Kc equals to 4.9. So what they have asked here, on the basis of Kc values explain whether the reaction is exothermic or endothermic. So I will explain you this now. So I will first write the equilibrium expression. So equilibrium constant expression we will write for this reaction. So it is denoted by Kc. So Kc equals to, so first we have to see the here product. So product form is H2O. So we will write in a square bracket in the numerator because product is always written in the numerator and carbon monoxide in the numerator. Now here upon then reactant we have to write. Now carbon dioxide and H2 are the reactant. So CO2 in a square bracket in the denominator and H2, even H2 is the reactant, so it will come here. So this is our expression for this. Now we will take two scenarios. Okay, so suppose numerator value is higher. Here as you can see Kc value got increased to 4.9 and here it is from 1.1 to 4.9. So we will take two scenarios so I can explain you better. So our first scenario, suppose it is there, suppose numerator value is greater. Okay, numerator value is greater, that means this one, suppose H2 and CO, when you solve this and it is coming to, just assume that it has come to 10 and denominator value has come to suppose it means denominator value is lower, so we'll take it as 5. So now 5 and 5, 5 to 10. So here in the first scenario the answer is coming more than 1, 2, that is 2. Now in the second scenario, okay, in the second scenario we will take in such a way that numerator will be lower value and denominator will be higher value. Okay, so numerator we will take as 5 and this we will take as 10. So here 5 ones are 5, 5 to the 10, that is coming to half. So half is equals to 0.5. So here you can see it is coming lower, the value is lower, it is coming lower. That means if this scenario, if 0.5 it is coming, that means it is reducing. Means here you can see it is reducing. That means reactant form is reactant is formed. Okay, reactant form is more. But whenever Kc value is coming more than 1 and it increases. So here you can see here it was 1.1 and it increased to 4.9. That means numerator value is increasing. So that means in the numerator what is the product, reactant. So here product. So in the numerator product is there. So that means product value is increasing and numerator value is also increasing. So in this way we can say that product value increases as the value of numerator increases. So in this way we can now I can explain you using a other way also. So let us assume that if the value of our numerator, that is product formed H2O and CO, becomes 15, okay, and our this reactant suppose 5 only, okay, but it reduces, so it is 5. So here you can see 5 and the 5, 5 3 is the 15. So from 2 to 3 it is increasing, that means it is increasing here. So that means it got increased. So that you can see here it got increased from 2 to 3. When numerator value is increasing, that means product formed is also increasing. And here they have given at two different temperature, 850 and 1700 degrees centigrade. So at 850 and at 1700 degrees centigrade, what is happening here? So here at 850 we can see the temperature is increased. So temperature is increased. For always remember, for exothermic reaction now, if you increase the temperature now, the reactant form will be more, product will be less. But here the value of Kc is increasing, that means product is increasing. That means it is endothermic reaction because it needs heat. So you have supplied heat. It was 850, now you have actually almost doubled it. So it became 1700 degrees centigrade. So it was needing heat and more the product is formed. That means the equilibrium has shifted towards the right side when you have increased the temperature. That means it was needing heat, so you have supplied heat. So it is endothermic reaction needs heat, so you have supplied the heat from this in the reactant, and so it was needing and you supplied it, you increase the temperature, and so more the product will be formed, as I have explained you this using this two analogies also. So let's solve the next part of our chemical equilibrium chapter. Okay, so thank you for watching my video. I will make further videos, so you can subscribe my channel also, and you can drop an email if you are interested in joining my online class or offline class. Thank you for watching. Take care. Bye.